Welcome to Grade 10 Science, Earth Science. I will be your teacher. My name is Mark Sauvé, and I will be teaching you 36 classes or 36 lessons along the way. So, as today's lesson, as we begin, today's lesson is kind of an introduction of everything, right? Something that we need to know about certain things about science, all the terms and all the different things that is very important and that helps you along the way. Okay? Now, what you need to do today's lesson is the nature of science. The nature of science. So everything that we need to know about today's lesson will be mainly about vocabulary and all the different things. Okay, so let's look over here. I have a chart of all the different important vocabulary that we find in the first lesson. First thing that we look at is astronomy. Astronomy, what is astronomy? It's the study of everything beyond the atmosphere. The atmosphere, so we have the Earth. Around the Earth, we have the atmosphere with the oxygen and all the different things, right? So beyond that, what we'll have is planets, moons, suns, all the different things. How do we study this? We have people that do that. They're called astronomers. And how do they study? How do these astronomers study everything that is up in space? We use telescopes. So these long, different things, we call them telescopes, right? That's astronomy, is the study of everything beyond our atmosphere. Second thing that we look at is meteorology, right? Everything that has to do with everything within our atmosphere. But this is mainly has to do with weather. So we have weather patterns, all the different things, atmospheric pressure. So you have pressure, atmospheric pressure, so different pressures have influences on different types of weather. You have tornadoes and all kinds of typhoons and everything that has to do with the weather. Is it going to rain? Is it going to snow? Is it going to be cold or hot, or all the different things? That has to do with meteorology. Usually when you watch the news on TV, you'll have the weather report. That has to do with people that are studying meteorology. Okay? So weather, pressure, all the different rains and all the different things, that's usually what we find in meteorology. Next thing that we look at is geology. What is geology? It's everything that makes up the Earth. But not living. These are all non-living things, all materials that we find, right? So materials, and it's all non-living things. What can be non-living? It can be rocks, right? Rocks and all kinds of different things that make up the Earth, glaciers and all kinds of different things, right? But these are all non-living things. Things that, or people that study geology are geologists, right? These are the people that study and they make all kinds of different conclusions and all kinds of different things. Okay? Geology. The next thing that we look at, oceanography. Right here, oceanography. What does that have to do? That has to do with the oceans, right? Oceanography. The main or key word is ocean. So everything that has to do with oceans, this is usually salt water, right? Salt water. And what do you have in the oceans? You have all the marine life, right? Marine life. And everything that has to do with the physical and the chemical balances of the oceans, right? So physical and chemical balances of oceans. Right? So anything that has to do with the makeup of an ocean. If you have a big oil tanker and the tanker crashes and oil spills out into the ocean, what happens? It changes the balance of the oceans. So maybe some marine life will die, some different things will change along the way, right? Different things that humans, us, you and me, and all of us, we change the balances of the oceans. Anyhow, oceanography, that's the study of oceans. Later on, we'll see more about that. Lithosphere, right? Lithosphere, it's a little bit challenging to say, but you have, this is the Earth, right? If you cut the Earth, right? You have different layers, right? Different layers. So you have the top layer, right, is called the crust. And you also have the mantle, right? These two parts, crust and mantle, they together form the lithosphere, right? Crust, you have two types of crust. You have oceanic crust. Oceanic crust. So this is, you have the ocean. Below the ocean, the first layer that you come across is the oceanic crust, okay? Types of rock that you find. This is the type of rock that you find. Basalt is the main type of rock in oceanic crust, okay? Second crust is continental, so it's over land, like where you have countries like Canada, North America, all the different places, Asia, all the land, we have continental crust. And this is usually formed with granite. This is the type of rock that we find is called granite, okay? Below the crust, this right here, the crust is very hard, right? Very hard. The mantle is a little bit more liquid, right? A little bit more liquid. But the type of rock that we find in this one here, we have all kinds of different, and this is called peridotite. This is the type of rock that we find in here, okay? So the top part, right? The top part of, or the first layer is called the lithosphere, and these are the two parts that you find in here. The second layer, right? Asthenosphere. So that's the second part, or second layer. And this is molten rock, which is liquid. Like I said here, these two are solid, so very hard. This second layer here, molten rock, is very liquid. Okay? Then as you go down further, we have the core. The core, so the core of the Earth, right? So first layer, second layer, and on the bottom part, we have the core. We have two parts. The upper is more liquid, and the bottom part, or the totally inside part, this is very solid. And this is solid, and you find different types of things inside there. You have iron and nickel, right? That's what you find in the core. So this is the inner part, or the crust. So you have the crust, the mantle, the second layer, which is molten, and then the core is on the inside. Okay? Now, if we look more over here, we have the next vocabulary, hydrosphere. Hydrosphere has to do with water. So hydrosphere is the study of water. Right? Everything that has to do with water. We have the oceans, the rivers, the lakes, and all the different things. Oceans, rivers, lakes, all bodies of water fall into this category here. Rivers, lakes, right? So now, where do we find the different types of water? 97% of the water is salt water. Salty water, which you find in oceans and seas, right? 3% is fresh water. Fresh water meaning no salt, right? So salt, no. So this has no salt in fresh water. Most of the fresh water is in icebergs and glaciers, right? Glaciers, and you have icebergs. 3% of the 3% are in these, glaciers and icebergs. The rest is usually found in different things, but usually underground, right? Under the ground, which we call groundwater, right? The rest usually is found in ground water. Ground meaning underground or above ground, right? Okay, now if we look at here, the next one, atmosphere. Atmosphere is everything that's above the ground and below the beyond atmosphere. So everything that has to do with within the ozone layer and below, right? Everything that's in the air is called atmosphere. Now, the atmosphere is 78% nitrogen, right? And roughly 21% oxygen, right? 78%, 21% oxygen. The rest, we have water vapor, CO2, which is carbon dioxide, and all kinds of different things. Like we have vapor, water vapor, that's when oceans or water evaporates, goes up into the sky. Vapor, we have CO2, which is carbon dioxide, and many other things, right? So atmosphere, we have people that study the atmosphere, right? That's new vocabulary. Biosphere, if we look over here, biosphere, it's everything living, right? All living things. Biosphere are living things. So bio meaning living, and sphere, all the environment. So living things and their environments. Right? All the living things like animals and plants and their environments. Like a bear. Does a bear just live on its own? No, it lives in a forest. So the forest is the environment. So all the different things, all these things here fall into the biosphere. Okay? Now, let's look at another list that we have here. So, what happens in science? In science, or scientists, they do different things, right? First thing they do is they see a problem. Maybe there's a problem, right? They make a hypothesis, right? Hypothesis, which is a guess about something, right? Then they do an experiment. They have analysis, and they have conclusions. Right? This is what you usually do when you're doing a scientific research or an experiment or all kinds of different things. You see a problem, right? And you guess. What's going to happen? You do an experiment, you analyze it, and you draw conclusions, right? Conclusions here usually make up theories. Theories. So after you have many, many, many different experiments and all the conclusions are the same, it becomes a theory. Okay? Something that isn't a theory is usually law. A law, like this chalk will fall. That is the law of gravity, right? So that's not necessarily a theory, but it's a law. Everything that you drop falls down. That's law. Okay, now when you want to do an experiment, right, you need to do different things. Hypothesis right here. We have a hypothesis, which is kind of like a guess. We have independent variable, so a variable that changes, right? Sometimes it changes and you control it as the person that makes the experiment, controls this variable. Dependent variable, it is affected by the independent variable. Okay, I'll show you a little bit more about that. Control, meaning that you take away all the other elements or all the other variables, so you just have two different variables, the independent and the dependent, together controlled, so that we know that that is the reason why something happened, right? That is the reason. SI, we'll see that a little bit further, okay? Let's see right now as an example. Right? After you do an experiment, how do you show everything? You have reports, right? You have graphs, and you have all kinds of different things, right, that show your results. Okay? I'll show you, let's say, a graph. Using a graph, let's say we have temperature. This is the independent variable. It's usually on the x-axis, and on the y-axis you have the dependent variable, and this is in a controlled experiment, right? Temperature, and let's say gas, certain gas, right? Temperature goes up, you raise the temperature, the gas gets bigger, right? So if you have your car, right, you're driving your car, in the summertime the tires expand, right? In the wintertime the tires get small. So this and this, so temperature gets higher, let's say 2 degrees, 4 degrees, 20 degrees Celsius, the gas gets wider or bigger, right? So that is the dependent or independent, and the gas is dependent. So the temperature goes up, the gas gets wider, right? It becomes dependent, okay? Now, if we look at SI, SI is short for a French term which is Système d'Unité Internationale, right? SI. So this is kind of like the metric system, and it's how we write all kinds of different things. So if you have, let's say, for example, length. How do we use length? Centimeters, meters, kilometers, right? We have weight. We use a force, it's called newtons, right? Mass. We have kilograms. We have area. Meters squared. Centimeters squared, right? An area. Volume. And volume, okay? I know this is a lot of information, but volume, centimeters cubed, meters cubed, liters, or milliliters, all kinds of different things for volume. You can also have density, right? Grams per centimeter cube, right? All kinds of different per centimeter cubed, right? All kinds of different things. So this is essentially a notation, right? So centimeters, newtons, kilograms, this is the system that we're using, right? Because all different countries have different systems, so we want to have a general, a good system that everyone around the world uses. Because in the United States, do they use for, let's say, for length? In the United States, they don't use this system here. They use miles, right? And they use different systems, right? So this is to have a standard all around the world, kind of the same standard, Okay? Same with time. Time we use seconds, minutes, hours, right? It's a standard for time. Okay? Now, the last thing that we're going to look at right here is the scientific notation. Right? Scientific notation, it means pretty much to the power of 10. Right? So it'd be 10, or let's say 9 times 10 to the 10. Right? This is the scientific notation. Right? Scientific notation, which you make a number a lot smaller. And these you just add, instead of writing 900000000, right? To make it a lot simpler, a lot easier to read, use 9 times 10 to the power of X number, right? That is the scientific notation that we find right here. And essentially, if you can figure out how to do all these things and you understand these terms, we'll have a good kind of course in the future. Okay? So I hope you had a good time, and I know there was a lot of information to take in for the first time, but once you have it all in, we can continue for the second lesson. Okay? See you next time for the next lesson. Bye-bye.